Indeed, my name is Dorien. I'm a research data manager at Utrecht University. That's a university based in the Netherlands. And I work at the research data management support team in the library. And we help researchers with all kinds of research data management questions. And data sharing is a very large part of those questions. So yeah, I think I hope I can help you get started if you want to share data and practice. One other thing that's maybe relevant to know is that in my previous job, I was also a data manager, but in a developmental neuroscience group. So I have a little bit of experience with neuroscience data as well, which I hope could be relevant for this audience as well. So when I was asked to do this workshop, I thought, okay, how should I structure this? And I thought, okay, what issues do we see most? And actually what happens most is that researchers come to us with a question about data sharing after they have collected their data, maybe even after they performed their analysis or the manuscript, and they find out that they haven't thought about sharing data before they started their research. So what I want to do is not only talk about how you can actually share your data, but also how you plan to do so. And then I will also talk a little bit about how to handle data during your study. And mostly, of course, I'll focus on archiving and sharing data after data collection. And there we come across terms like fair data, as Georgia already stipulated a little bit, and anonymous versus personal data sharing. So, oh yeah, one thing I did want to mention is that the exact procedures and tools that are available may differ a lot between universities, maybe even between faculties of the university. At least in our case, that's often the case. So I would always recommend to go to a support person within a university to ask what exactly are the guidelines that you should be taking into account. And in our university, these people are often called data managers or data stewards or privacy officers, but I've also heard many other terms for these support people, but yeah, go to them and ask for their help because they're there to help often. So when planning research projects, the things that I often think about is planning data management, privacy, and ethics. And the things I think are most important to think about beforehand are what data will you actually collect? And if you're collecting personal data, then you should minimize how much data you are actually collecting only for the purpose that you need. And as Georgia also already stipulated, the GDPR asks to specify why you need to collect those data. So you have to collect the data for a very specific purpose, for example, a very specific research question that you want to answer. And then a separate question is what data will you actually share? Because this can be different. You don't have to share all the data that you collect. And in fact, if you want to share data that are personal, then you should either plan to anonymize the data, making the data not subject to the GDPR anymore, or obtain consent for data sharing, or maybe if you can use another legal ground, that may also be possible. And very concretely, it's also useful to think about very concrete stuff like what type of data do I have and how large are the data? Because this has consequences for example, where you can store your data and how you will share the data after your project is ended. And if you're working on a large project, for example, it may also be that you deal with other people who are working on the same data set. So you have to think, okay, am I going to share the data, or are they going to share the data, or are we going to do it together, or am I sharing only the data underlying my paper or from the entire project, etc. Then thirdly, are there any restrictions to sharing the data? So this has to do, especially for the purposes, why will you share the data? Will others only be able to validate your results? Or should they be able to answer new research questions with the data that you share? With whom will you share the data? So maybe only with your team or with all academic researchers, or maybe even publicly? And is there a time limit to when you will share the data? So, for example, you could put an embargo on the data. And do you need any agreements? Do people need to sign an agreement before they can access the data? And lastly, what's also important to take into account is who is actually responsible for this process, and how much will this cost? And I think the costs ideally would be taken into account very early on, maybe even with the grant proposal or the grant application. But if not, it's probably good to take into account that it may cost some money and some time to, for example, if you're sharing data under restricted access, who is going to take care of these data requests, and how will the data be maintained, as to speak, after the research has finished? Okay, and so all of these things, it differs also per university a little bit, but for example, at our university, all researchers have to fill out the data management plan, and the data management plan often contains all of this information and more practical information as well, usually. And sometimes the ethics committee also asks for this kind of information. But what's also important is that because participants have the right to be informed, as Georgia already mentioned. So you should be transparent to participants of the research as well as to what you're doing with their data and who will access the data later on. So just one side step. This is a question I got a lot in my previous job. Can brain data, can neural data actually be anonymized? Or should we see it as personal data? And I will take as an example MRI data, and that's only because that's what I have most experience with. So in MRI data, you have different components that can be identifiable. So one component is that DICOM files often contain header information, and this header information can simply be removed if you want to take that out. Then if you make an anatomical MRI scan, you are also often scanning the face along with it, which is directly identifying information. But this can easily be removed as well with defacing software, although it may not always be desirable to do so, but you can take it out. Then there's also accompanying data that's often collected. I don't think it ever happens that you only collect imaging data. It's also often at least some demographic information, and it may be possible to link data to a person through this accompanying data. So one example could be if you scan a 92-year-old man, and from the scan you can see, oh, he has a tumor here or there, that may already be identifiable. And of course you can try anonymizing this accompanying data as well. But the thing that is of most concern for brain imaging data is that there are a lot of data points. And these data points, so either functional patterns or anatomical images, these can actually function as a fingerprint. So the combination of these points are actually so unique to someone that it's very difficult to actually anonymize this. And for this reason, I think we should consider neuroimaging data as personal data, even if you take out all of the other stuff. So then what that means is that we have to consider this personal data, and we have to comply with the GDPR. And that means that we have to have a legal basis if we want to share that type of data, if we want to process that type of data, actually. And if we can consider this health data, then we have to get informed consent. We have to protect the data, so pseudonymize the data and minimize the data and separate the data from other identifying information and use secure tools, for example. And we should enable data subject rights as well. So people should be able to withdraw their consent, for example. So about informed consent, there are lots of templates out there, and they probably also differ per institution. One example that can be used to start is the Open Brain Consent template. However, I would advise you to still go to someone who knows about this at your university or institute, because the exact formulation may differ. And I mean, I've heard now that in Italy, there's also specific additional regulations that you need to take into account. So it's always useful to contact someone. So what you should always do in an information letter is to be transparent about what you will collect and what you will share and with whom and for which purposes. And be explicit about which risks are involved and provide contact information. And it's not wise to promise that you will process the data anonymously, especially if you're already collecting personal data, then you're already not fulfilling that promise. And it's often very difficult to fully anonymize personal data. So it's not very wise to say, okay, it will be completely anonymous, because you're making a promise that you may not be able to keep. And also try not to promise that you will publish data publicly if you cannot guarantee the participant's privacy. And here in the middle, there's a nice sentence from the Overbrinkelsense template that I thought was quite nice because it's very transparent to participants about the risks, for example. About the execution of research, I'm going to be short. You should just use secure tools, and which tools is also institution dependent, probably. Use best practices in your research. So one best practice that I wanted to highlight is the brain imaging data standard. This is, from a data management perspective, is the ideal situation because it's a standard way of structuring files, naming files, but also which file types you should use and how you should document your data. And it's also very widely used across the imaging community. So if you haven't heard from it, they have very good documentation as well. I would highly recommend using it in your data. And documentation otherwise, if it's not already in bits, then other documentation is also always good to keep, because it's good to keep for version control, but also just tracking what did you do, how were the data collected, how were the data analyzed, what's the project about, etc. Then if you're working with personal data, I've linked here, I think we will share the slides as well. But I've linked here a nice small booklet about privacy design strategies, which are a little bit more concrete strategies of how to deal with personal data. And there's sort of 8 strategies that you can use. And you may also need agreements during your research. And I think a legal team can help with this. So let's say you've now collected data, you've analyzed it, and now you want to share the data. And there are a few things that you can always do, or maybe that you should always do. And there are a few things you may or may not be able to do. And the things that you should always do is pseudonymize data as early as you can. Of course, taking into account which data you still need, because it may be that you cannot anonymize or pseudonymize the data because you may just need some personal details. But if you can take the details out, you should do it. And then in order to make your data fair, I will come back to that. You should publish at least your metadata and documentation in the data repository. So even if you cannot share the data, you can still share metadata and documentation so that others can find your data set. And depending on your scenario, you can or maybe cannot share your data. And I will come back to these scenarios in a later slide as well. So step 1 is to pseudonymize the data. And there are, of course, many different types of data. So this slide is just a selection of possible types of data. But I think the most important ones are, for example, demographic information, because I think in almost every research project, demographic information is collected. And there are also some nice tools. So Amnesia and ARCS, these are anonymization tools that you can use to anonymize these data. But of course, you have to take into account if the data are still valuable, because otherwise, why would you anonymize the data if they're not useful after all? And for DICOM images, as I said, you can remove information from the header files, defaced images, and you can also separate raw images from defaced images, for example. So you control access to those. If you have short research projects that don't last longer, so no longitudinal studies, then you could also think of removing or replacing subject identifiers, because often subject identifiers are still linkable to a file where there's a name connected to that identifier. But if you replace or remove those identifiers, then you've also removed the link with their names, for example. And yeah, if you have free text in your data, you should check it or replace it or maybe remove it. And there's also often tools available for that. Yeah, in order to create a fair data set, you should at least publish your metadata and documentation in a data repository, even if you cannot share the data yourself. And fair are indeed some good principles for research data that relate to your data set as an output, as a research output. So it stands for findable, accessible, interoperable, and reusable. And in order to make your data set findable, well, you should just choose a data repository that gives your data set a persistent identifier. One example of a persistent identifier is a DOI, so a digital object identifier. And that gives your data set some metadata. So for example, the title of the project or the authors or the year or the version, that kind of information. And that kind of information also allows others to find your data set. What you should also do is interlink your outputs. So if you deposit your metadata, maybe even your data in a repository, you should also say, oh, this data set underlies this publication. And in the publication, you say, oh, you can find the data set here. As Georgia already said, accessible doesn't mean open. So you have to specify if and how your data is available and how people can access the data. Doesn't mean that you have to publicly publish your data. So your data can indeed still be fair, but not open. Interoperability means that others can easily combine data sets and can easily, for example, open your data files. And for this, if you're using neuroimaging data, then I would recommend to use BITS, because BITS is a very interoperable data structure and use open formats, but that's actually also already specified in the BITS structure. And then reusable usually means that you should provide an open license to your data set. Well, that's not always possible if you publish just the metadata, or if you publish data under restricted access. But what does make your data reusable as well is to provide lots and lots of documentation. So for example, standard operating practices, how were the data collected, how were the data analyzed, code books, README files, etc. And all of that information helps others understand the context of your data set and what happens to the data. So yeah, let's say you've collected all the documentation and now you say, yeah, I also actually want to share my data. Then I think there are three main scenarios. So either your data are fully anonymous, and if they are not, they are personal. So if they are personal, you can either have a legal basis to share the data, or you don't have a legal basis to share the data. And I'm intentionally phrasing that very vague. You have a legal basis to share data, because this is really something that you should discuss with someone at your institute. Do you actually have a legal basis to share the data? So if your data are really, really fully anonymous, then you can publish the data alongside the metadata and documentation in the repository that you chose. But of course, there may also be other reasons why you don't want to do it besides privacy. I think Georgia already gave some nice examples of why you may not be able to publish it publicly. If you do have a legal basis to share the data, and so you have personal data, then my recommendation would be to share the data under restricted access. So either some data repositories have restricted access options, and if they don't, you should make sort of a workflow as to how people can access the data. And the preference is to add someone to an existing infrastructure, so you can also remove their access very quickly, and the control lies with you, instead of just sending the data away and having no control over it at all anymore. And if you don't have a legal basis to share the data, there are some alternatives that I will go into very quickly at the end. How much time do you have? Okay. These are a few examples of repositories where you can deposit Neuro data. I think OpenNeuro is used very often, but it's used very often outside of the EU. And that's with reason, because it's a US repository, and it only has a public access option. So you cannot publish restricted access on OpenNeuro. And OpenNeuro also states very explicitly, you cannot deposit data here if your data are subject to the GDPR, which means that if your data are still personal, you cannot deposit it there. But there are some things in development that are relevant. So eBrains is, I think, rapidly developing now. I don't have that many details, but they have some nice information on their website, and they will allow, or they maybe already do allow, restricted access publishing, and they're based in the EU as well. And then if you decide not to publish your data in a repository at all, it maybe doesn't always matter which repository you choose, but people often choose general purpose repositories for that. So Zenodo, for example, or Open Science Framework, or Figshare. And if there's nothing in between these repositories, there's also a nice website where you can search for other repositories. It's called re3data.org. And they are a registry of repositories, so you can choose another one there as well. If you cannot deposit your data in such a public repository, you can share with access restrictions. So if you have personal data, I think you should always think how you will protect those data. And possible access restrictions are to use data sharing or data transfer agreement. And such agreements restrict the use of the data. So for example, they state that the user cannot re-identify or not try to re-identify the participants, or they cannot share the data with third parties, etc. And these agreements are mandatory when you share the data outside of the EU. So I put EEA here. It stands for European Economic Area. It's basically the EU and some few additional countries. If you want to use such an agreement, then just discuss that with the legal department, and also discuss who has to sign these agreements, because that also differs a lot between universities or between institutions. There are also other restrictions that you can think of. For example, some studies require that reusers have to write a research proposal, and the research proposal will be assessed on the validity, for example. Some projects require that the reuser has an affiliation with a research institute. They may have to agree to a data use agreement, which is basically a custom license, where you maybe have a time restriction, so an embargo, and there are many other restrictions to think of. What's important is that you're transparent to reusers about what are the restrictions, and maybe also to the participants, because it's their data, so they have a right to know what's happening to that data. Then there's also options to share derived data. I think the most well-known for neuro data is NeuroVault. You can publish, I think, statistical maps and contrasts on there. So those are group data, so they're not personal data, but they're still very useful because they can allow meta-analysis to be performed, and they're still some part of the data that you're sharing then. And some other options are, one concept is called coded data. And basically that means that you send codes to the data without seeing the data. The code is run locally and then you only see the results as a return. So that means you don't actually have to share the data. Maybe you have to share the synthetic version of the data so people can actually write their code. But then you don't have to share the data itself. And a more advanced idea of this is federated or distributed analysis, and it's basically the same idea but then with multiple data sources. So there it's come from artificial intelligence, and well, their model is trained locally and is aggregated on a central level. So you learn things from the data but not the individual data points itself. And there are some examples on the slide, but there are probably lots more. This is not my expertise, but I know that it's I think it's a very elegant solution. And then two other things that I wanted to highlight really quickly is that there's also something called confidential computing. This actually allows to compute securely, so the analysis is secure. And synthetic data means that you make sort of a fake version of your data. And that can happen on a spectrum. So you can either, on the one hand, one side of the spectrum, there's synthetic data that only is similar in the structure of the data, or has the same structure as the original data. And on the other end of the spectrum, the data have the same statistical properties as well. And there's also, that spectrum is also a little bit a spectrum of identifiability. So if you only have the same structure of the data set is, well, a lot less sensitive than if you're also taking into account the statistical properties of the data set. And there are many packages available to make a synthetic data set, and it's often used for tabular data set. And for MRI data, there are some nice resources on this website. So in short, there are a few take-home messages that I wanted to emphasize. So firstly, planning is a really large part of sharing data. And also it's important to be transparent about what you will do with the data, with whom you will share it. And your planning documents can also function as documentation where you can show that you're compliant with the GDPR, for example. You can always publish your metadata and documentation, of course, provided that they don't contain sensitive data, but often they don't. So yeah, it's good to be transparent with that. And if you publish it in data repository, then you also have something additional to cite, so an additional research output that you get recognition for. If you have personal data, you should first have a legal basis, of course, to process the data and pseudonymize protected data. You can always share derived data and anonymous data. Well, actually, derived data are anonymous, I'm assuming. And if needed, you could use alternatives such as synthetic data, coded data solutions. Yeah, and that was, I think, that was it, I think, yeah. So questions are welcome. And otherwise, maybe we can move on.
Yeah, thanks, Dorien. I think we have already a question by Professor Castle.
Yeah, go ahead.
So it's yours.
Thank you so much, Dorien, for your presentation. Very interesting. I have essentially two questions. How much large is your team, your office, your body in the University of Utrecht? Just to have an idea of the dimension of the task. And the second one is about the role of the state. The Netherlands state, what is the support you received from the state? You have because I know there is a national plan on open science in Netherlands. It was one of the first in Europe, and there is a strategy in Netherlands very precise about the promotion of open science.
Yeah.
Because in Italy, the situation is very complex. Georgia mentioned before the national plan on open science, but it is very recent and not yet in implementation. So for now, there are only words, and we have a lot of difficulties to receive a real support from the state, from the Ministry of the Education of the university in this field. Thank you.
Okay, yeah. So the first question was, how large is our team? Well, we at the library, I think we're with 6 or 7 people within our team. So our team research data management support, that's within the library. And then often the faculties also, the faculties within the university, some of them also have a data steward or a data manager for the faculty. And for one faculty, they also hired for different departments within the faculty, they also hired some data managers. And we also have support for privacy. So every faculty has a privacy person, privacy officer, they call it, available. So there is quite some support, but it's still, our university is quite large. So we find that it's still not sufficient, but it's better than nothing. And we are a good start, and there are policies within the university around it. So that's quite all right. And then the second question was, sorry, does that answer your question before I move on?
The second question is about the role of the state, and if you receive a support of the state, eventually what kind of support?
In terms of money, I don't know. That's probably a question for our manager. But I think, yeah, there are, so for example, nationally, we also have a funder call for open, so they have open science funding goals. Both support people and researchers can sort of apply for that kind of funding. Yeah, so some of our projects are funded by these national goals, also for infrastructure projects and some research projects. And yeah, so in that sense, there is support, and I think most of the support is in policy. I mean, in the Netherlands, I think, I'm not particularly sure, but I think because of this national plan, and it's also sort of in legislation, and one example is that they want us to reach 100% open access publications, for example. And so I think that way we're getting support in terms of, okay, we have to do this, and then universities make their own policies on top of those national policies, which enable us to actually implement that in practice, I think. In terms of money, I'm not super sure. And there are also, it's a sort of a mix between policy, and there are also grassroots initiatives. For example, the open science communities we also have in the Netherlands. Every university has an open science community. Those are grassroots, so from bottom up initiatives. Yeah, and for example, I'm a data manager, and there are lots of other data managers at other universities. So we also have a sort of a national network for these support people, where every support person is welcome. So I think there's a lot of, there's many things going on at the same time, I think. Yeah, I hope that answers your question. I'm not sure.
Perfectly. Thank you so much. Thank you so much.
Okay, great.
There's another question by Carlo Mies.
Yeah, thank you, Dorien, for your interesting presentation. I have few questions, triggered from the Roberto question. The first one is, Do you have regular courses there to inform, to train a researcher on what to do on open science? And then are those courses compulsory, like a safety course or stuff like that? And related to this, what is, in your view, the best strategy to diffuse, inform, promote open science?
That's a very difficult question. But for the first one, yeah, we do offer courses, and they are actually, some of the courses are openly available, so actually everyone can follow them. We have an introduction about research data management, because we are from research data management support, but there are also open science courses, and it's basically in our university, it's a little bit spread. So we have these central courses that we offer, but some faculties also offer their own courses. And sometimes we join those efforts. So it's a little bit spread around the university, but no, those are not mandatory. I think it's also, I think it's a little bit our strategy that we don't want to force things on researchers. We are there to help them. So if they need help, they can come to us, they can ask us questions, they can follow our courses. But we are not there. That's not the nature of our department to sort of impose ourselves onto researchers and make them follow this many mandatory courses. But in terms of privacy and security, I think this is something that we want to do. So I think at the moment we are actually working on a privacy course for researchers, because we've noticed that there's still a lot of gaps in awareness, for example, as to how to deal with privacy, and just some terms of vocabulary in privacy is sometimes missing. And that makes communication with support people also difficult and, well, takes long. So in terms of that, there are many different things running, not only from our department, but also from information security and privacy experts at our university. But our courses in general are not mandatory. And what was the second question again? Sorry.
The second question was, in your view, what's the best strategy to promote, let's say, this kind of approaches, open science, data sharing, or data treatment, etc.?
It differs very much on the audience, I think. So what I've noticed at the previous university I worked, they tried to push it from the bottom up. So when educating PhD students, for example, PhD students, they all have to write a data management plan. And when writing a data management plan, actually in our university, all researchers have to write something like that. And that makes them also aware of these issues, because our template, our DMP template is just often contains also these questions about how to make your data fair and with whom will you share the data. And that's already, because it's an obligation, people have to look at it. But we've also seen that it's easier to educate the younger researchers or the early career researchers, because they are still new and they're not set in their ways yet. And the researchers that are often a bit older, if they've done research for a longer time, it's much more difficult to change how they work. But of course, it differs also on the size of the organization, I think, because you may also be able to start from the top and educate all the PIs, for example, and then the PIs teach their PhD students how to work, how this is sort of, this should be the new normal or something. Yeah, I don't know. It's very difficult because I don't have that many years of working experience at the university, and I've also seen every university tackles this differently, and even in our university, even every faculty tackles this differently. Yeah,
I see that's pretty much the same everywhere, and also consider that, as you become older, your brain is less prone to learn, so it's less plastic. So
Yeah.
for sure, it's better to start from students and so on. And sorry, then I have another additional question. So when you were introducing MRI, you said, yes, if you got data there, obviously data at the header of the file can help you in identifying the subjects and so the phase, so on. And then you ended up saying, if there's a subject with given age with the tumor, then also that is a sort of fingerprint. I'm not really sure about that, because while names can be searched in database or face of a person can be searched around, then it's going to be difficult to find a person with the tumor, because it's not common to have around MRI images, especially if those images are not bound to a name or to a person. So are you, I mean, is it true that it's a fingerprint to have the brain of the subject with a given pathology? Unless it's very specific one, very rare one, like, I don't know, 5 in a nation. Otherwise, unfortunately, tumors are quite common. And so maybe they're not so specific.
Yeah, that may also just depend on the data set. But I think under the GDPR, something is personal also if it's indirectly identifiable. But I have had this discussion lots of times. So when should we consider this personal data, because you cannot just scan someone's head, so that information is not it's not directly identifiable. But I think it's also a little bit being on the safe side that we should consider this personal data. But yeah, this is also a bit opinionated. I agree. It's a little bit of a gray area. Yeah, maybe, I don't know. I'm also curious if Georgia has ideas about this. Sorry to put you on the spot.
In the literature, the debate is spread as follows. In the big data area, if the personal data is not identifiable through that database, so the one that collects, for example, the brain images, but through the combination, the connection with another database that is available in the same institution or in a local institution or is open online, then the data collected in the first database can identify indirectly the natural person, so the data subject. So in the big data dimension, it will be easier to re-identify or identify the natural person, not by the use of the first database, the one that the research group is using to perform the research, but eventually by the use of another or more database available online or even accessible online. This is why Article 29 Working Party Group, when writing the opinion on anonymization, asked to the anonymizer function to be very highly level to avoid any possible connection between an identity of a person and the data. And in the healthcare domain, I think it will be easier to have almost every time possible re-identifiable data, but we will see. I don't know.
Enrico?
Yeah, so I get this kind of questions when I teach about anonymization, and what I like it's one should come up with a number of anonymity. There are some numbers like this, like K anonymity. So maybe a 50-year-old male with a brain tumor, even if let's say you can get a list of all the 50-year-old males in Italy with a tumor from all the hospitals, maybe you still end up with, I don't know, I'm inventing 1,000 subjects. And then it might be difficult if that's all you know. It might be impossible. But then you start having maybe a male who is 102-year-old with a brain tumor. Maybe you get 3 people, and so there the K anonymity would be 3. You could ask these 3 people, is it you that went to that hospital to take an MRI? and then the data in this sense is a fingerprint. What I give as example often is thinking of the actual fingerprints, because if I give you a picture of my fingerprint, you're not going to be able, I mean, unless I tell you it's me, you're not going to be able to do that. Or then but you know that somebody with that information can go to the police, and the police maybe could issue, yes, we can start searching through all the database of fingerprints, and then, you know, again, with some error, they will identify me. So I think I agree with Georgia that you know, if there is a chance, even though the chance is smaller than the p-values that we work with, we still need to, you know, we still need to be ethical even to the individual and say, yes, there is a probability of 10 to the minus 12 that you can be re-identified. But this is also, I'm going to touch this on my talk soon, that do we really need, you know, overthink these impossible scenarios, or should we just simplify it? You know, if the probability is less than 1 in a million, maybe, you know, it's anonymous, even though there is a, but